This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Welcome to another episode of SE Radio. My name is Johannes, and today I want to talk about continuous delivery. And with me is Jez Humble. Welcome to the show.
Thanks very much. Thanks for having me on.
So who is Jez Humble? Jez Humble is currently Vice President at Chef, and he has 14 years of experience in IT. He worked, among other things, as a developer, a sysadmin, and a consultant. And the interesting thing is he apparently started programming with 11 years and was fascinated by his then ZX Spectrum. But he went on to have a BA in physics and philosophy at Oxford. Most people will probably know him about or one of the authors of Continuous Delivery and also of his upcoming book, Lean Enterprise.
That's right. Thank you.
So today's show will be mainly about the Continuous Delivery book and what happened since you published it in 2011. So maybe, Jez, can you start with giving us a 10,000 feet overview over continuous delivery?
Sure. So continuous delivery came from the experiences that me and a bunch of other people working at ThoughtWorks had, where we were working on these pretty large, complex projects, and release would always be a really painful process. And it was somewhere where ThoughtWorks wasn't really involved. We would tend to be doing the development work, and then the software would have to go somewhere else to be kind of released to production. And that was always a very difficult and painful process. And I think, obviously ThoughtWorks were one of the people who pioneered and helped popularize continuous integration. So we were pretty good at actually integrating the code regularly and running automated tests regularly. But what we would find is that wasn't enough to get it production ready. And the particular project that I worked on that really woke me up to these problems was a broadband provisioning system that we wrote for an ISP, where we were all working on Windows laptops, but the software was going to be deployed to a Solaris cluster. And the first time we were able to get our hands on a production-like environment was over 6 months into the project, and it took us 2-3 weeks to get it deployed. And when we got it deployed, we found all these architectural problems that were caused by people making bad assumptions. So people would do things like caching data to the file system, which works fine on a Windows laptop, doesn't work in a cluster because there's all the servers have a different file system. So we found all these problems, and it was really expensive to fix them. And there was some automated scripts to help build and deploy the system that were written in Ant, but the operations team, they were not interested in using Ant. So, we asked them, what do you want to use to deploy to production? They said, we want to use Bash. And so I ended up writing the system in Bash to do the deployment, called Conan the Deployer, after the kind of cult American film featuring Arnold Schwarzenegger. And there was a team of 8 of us in the end who were building and evolving this software so that we could deploy regularly to test environments and get test feedback and deploy to production. And so all of these techniques went into the continuous delivery book. And I think kind of what made it successful was that people working in large-scale web systems were simultaneously using very similar techniques. So while we were writing the book, the InView people, that was the company that Eric Ries co-founded, Tim Fitz wrote this blog post about continuous deployment at InView that caused a huge storm because they were deploying to production multiple times a day. And then obviously John Allspaw and Paul Hammond at the time it was at Flickr, did their talk at Velocity 2009 about deploying 10 times a day. Then the whole cloud thing was coming up, DevOps was coming out, So I think there was a confluence of people who all at the same time came upon the same set of techniques that went into continuous delivery. But fundamentally, all that continuous delivery is about changing the economics of the software delivery process to make it economic to work in small batches. So the reason we have these very waterfall processes still, even in agile shops, is because the process of going from starting up a project to getting approval to budget sign off to requirements to then development and then integration and release is still a pretty expensive process. So it's not economic to work in small incremental steps. And what continuous delivery really does is changes the economics of that so that you can work in small batches and take small changes through.
Yeah. So, and you achieve that by saying it in one sentence, automating everything from the start to the end, from the check-in to the deployment.
So that's one piece of it. Having an automated process for going from check-in to release is one part of it. I think architecture is another part. Configuration management is another part, making sure that everything that you need to reproduce your production environment is in version control. And then also there's a bunch of practices like continuous integration that also have to be followed in order to be able to do it effectively.
Yeah. Before we dive deeper into the topic of configuration management and continuous delivery, continuous integration, can you give me an example of a successful project you did with continuous delivery to make it more real for people?
Yeah, so the ISP is one example. The other thing, people assume that continuous delivery is for web software, but that's really not the case. So I was product manager for an open source tool called Go, continuous delivery tool, and that was packaged software. But we implemented continuous delivery there in the sense that every change would result in packages being created, and then we would run automated tests, but we would also create installers. So we would create Solaris installers, Windows installers, macOS installers, various flavors of Linux installer, and I don't think we do the Solaris ones anymore. We do the other ones still. And we would actually do upgrade testing. So we'd have a deployment pipeline that created the installers, and then we would have copies of some of our customers' production environments that have been data scrubbed, and we'd practice taking that environment and running the installer to upgrade it and making sure that the upgrade process worked using the installers. So that was great for packaged software, and it was very effective because it meant that release was simply uploading the installers to the FTP site where people could download them. The other example that I find really interesting that I wasn't personally involved in, although I do know the guy who wrote the book. It's a book called I think it's called Large Scale Agile Development by a guy called Gary Groover, and it's about HP LaserJet firmware and how they implemented continuous delivery for HP LaserJet firmware. Now, people don't upgrade their firmware 10 times a day normally. That's not something that you see very often. And yet, nevertheless, they implemented continuous delivery in the sense of having a very comprehensive suite of automated tests, everyone checking into trunk. And it was a very large team. It was 400 people distributed across 3 countries working on what became a 10 million line code base. And they were able to push in about 100 changes a day, about 100,000 lines of code changing every day. And they got about 10 good builds out of trunk every day, and then ran this extensive battery of automated tests. And they would get complete regression feedback within 1 day on the quality of that. And they made sure that they fixed any bugs they found straight away so that the software was always in a releasable state. And that made a huge difference to the economics of their process. They were able to get an 8 times productivity increase in terms of the amount of time the team was spending on building features and fixing bugs rather than, activities like manual testing or merging code between branches because they weren't using a trunk-based development process before. And all these kind of non-value add activities, a lot of that just got taken away. And it meant because they had no more stabilization and integration phase, they could introduce new features very late in the development process after what would have been feature freeze before. And that changed their relationship with the marketing and sales people as well.
So when I hear you talking, it sounds a lot like continuous delivery brings a lot of advantages for business. But when I look at it as the developer, is there anything which is for me, except that the business obviously pays me?
Right, which is a great question. I think there's actually a lot not to like for developers in continuous delivery. One of my favorite articles about continuous delivery is, it's not actually primarily about continuous delivery, but it touches on it, is a post that Steve Yege wrote. So Steve Yege, if you just type Steve Yege's platform rant into Google, it's
We usually link that in the show notes.
Great,
anyway.
That's perfect. So it's Yegge. He wrote this big rant about how Google doesn't understand platforms in the way that Amazon does. One of the things he talks about is how for developers working at Amazon, it was really painful because you had to do all these things like making sure the code worked in production and understanding about monitoring and stuff like that were not part of what most engineers understand to be their job. And so you were doing all this other stuff that prevented you from just hacking out code. And that was pretty annoying. But this comes from Werner Vogels, who is CTO of Amazon. He has this saying, you build it, you run it. So the people who are responsible for building the software also have to run it in production. And that means you have to understand how to do that. And that's a big culture change for developers. But it's also a really important feedback loop because it means developers have to understand what it means to have production-ready code, not just dev-complete code. And that's super important for developers to actually understand that, because then you have to really think about these concerns like scalability and availability and writing log messages that are useful and not just pages and pages of null pointer exceptions and things like archiving data. These are all concerns that developers have to build the software with these things in mind. And unless you have that feedback loop of understanding what it's like to operate the software you build, it's very difficult for developers to learn that stuff. So that can actually be really annoying for developers. The other thing that's a big culture change for developers is working out how to take big features and break them into small incremental steps that are deployable, that can go into trunk and be deployed, even though they're not finished, rather than working on feature branches. And that's a big culture change for developers because it slows them down in a sense, in that going from A to B in small incremental steps might take longer than it would if you were on a feature branch. But I think what's really nice about it, to come back to your question, is that it means that as a developer, you can take an idea, push something into production, and immediately see the impact of that. And you get this really tight feedback loop of doing something, and then maybe even the same day, certainly within a week, actually being able to see people actually interacting with that code, rather than the traditional model where you have to wait weeks or even months to see. I've worked on projects where the software went live after I'd already left the project and was working on something else. So I never got to see people actually using the software I built. And that's pretty miserable as a developer. It's nice to actually be able to push stuff out and see people use it and get feedback on it. I think that's actually really, really great.
Yeah. Has your approach to developing software changed since you are, like you would say, nearer to the customer, since you're nearer to your users?
It's funny because I never really experienced the bad way of doing it. I mean, my first job after I graduated from college was working at a startup in London, where I like to joke that we were doing continuous delivery, continuous deployment even, because we were FTPing files directly from our workstations into production. Back in 2000, we weren't even using version control. It was just, there was me and the guy who was the CTO, and we just FTP'd stuff. Which I certainly wouldn't recommend now, but it was fun at the time. And then I went from there to ThoughtWorks, where we were working on these big projects, where we had these problems we talked about. So my first experience was working in a continuous deployment environment. I definitely felt the pain of what it was like to not be doing that and just be hacking out code for weeks and weeks that never saw any real users. And obviously that was much worse. But I think if you've never experienced it, it can be hard to see what the benefits are. And this is just a problem with developers in general. I mean, I never used to do any kind of TDD before I joined ThoughtWorks. And then I went to work on a team where everyone did, and I was brainwashed. But I have Stockholm syndrome. I love doing it that way. I would never do it any other way now. So I think, I've had that experience of going from A to B. And I remember when the XP book first came out and I read it and I was like, oh, this will never work. And then I went to work at ThoughtWorks with people who did TDD, and it was just the way they developed software. And I was like, I had an epiphany. Oh my God, not only does this work, but it's so much more fun as a way of developing software than doing it any other way. So I think it's so difficult to kind of rationalize and try and convince people using rational arguments. The only way to do it is to try it for yourself and work with people who love doing it that way. And even then it will take you months to work out how to do it.
That's actually a good point. So, assuming I'm in a waterfall shop, I have a large multi-million website, whatever. How do I start with continuous delivery?
Yeah, that's a great question. And it is really hard because there's so much that needs to change. It's not just the development process, it's how you think about project management, it's how you think about even the budgeting process and risk management as well. All that stuff has to change. And I think the only way is to do it slowly and incrementally. As with product development,
is there some particular thing where you think you would start with?
So I'll give you an example from Amazon. Amazon actually re-architected from a monolithic architecture to a service-oriented architecture. And it took them 4 years to do it. And they used a pattern that Martin Fowler and other people have blogged about extensively called the Strangler application pattern. Because often the architecture is the biggest obstacle, or one of the biggest obstacles practically to achieving continuous delivery. If you have to deploy everything in the world, all your systems in a big bang way, it's very difficult to see some of the benefits. So what Amazon did was they re-architected to a service-oriented architecture, but they did it incrementally. So they would peel off a particular service and re-implement that. And over time, they would gradually peel more and more services out. And it's like, the metaphor for the Strangler application is in tropical rainforests, you have these trees, and then there's a fig vine that grows up around the tree and gradually strangles the tree, and all that's left is the fig vine, and the tree that it's grown around dies. And that's what we're trying to do architecturally, pull out all these little services and then gradually strangle the monolithic app. And that was, I think what Amazon did, which was really clever, was combine that with an organizational change, which was you build it, you run it. The idea that they had a team that was responsible for each service throughout its entire life cycle. And they had this idea of 2 pizza teams, that there was no team that would be bigger than you could feed with 2 pizzas. So no more than about 10 people. And that was responsible for that service over its life cycle. And so that imposes a limit on the size of the service, which I think, we're seeing an upsurge of interest in microservices, which is kind of the architecture that Amazon pioneered, although there's some argument about what defines the micro of the microservice, obviously. Yeah. And I think what was clever about Amazon is that they leveraged Conway's law. So Conway's law says that the architecture of a system reflects its communication structure, or is determined by the communication structure of the organization that builds that architecture. And so by saying, okay, we're going to have this service-oriented architecture and we're going to have 1 team per service, that was a really smart move. And again, Steve Yeager's Platform Rant talks about this. They actually hired an ex-Army Ranger whose job it was to go to all of the teams and make sure they weren't talking to other teams' databases. So this guy, Rick Dalziel, would go around, and if he found you talking to another team's database, not through their service layer, he would shout at you a lot. And, if you carried on doing it, he would try and have you fired.
Yeah. Coming back to Conway's law, so what you're effectively saying is by putting the people responsible for operations in the development team together with the business teams, you create the need for continuous delivery because people are sitting together, working together, have the same boss. And so they start dealing with deployment together, which leads to continuous delivery.
That's right. And the architecture as well, because the architecture is a key part. But yeah, you've created cross-functional teams, which means that, again, coming back to the idea of making it economic to work in small batches, you've got the architectural piece, and you've also got the team structure where developers can push changes themselves out to production. They don't need to go through this very onerous centralized change management process to get things out. They can just push things out within their team. So yeah, it's the organizational part and the architectural part, and they're aligned.
Changing a bit the topic and going a little bit deeper into the process of continuous delivery. In your book, you say a release should not be scary. Why are releases scary these days?
I think releases are scary for a few reasons. Firstly, in a lot of organizations which haven't architected their software for continuous delivery, it's just a very onerous process getting releases out. So I'm sure people listening to this show, there'll be a number of you who push out releases outside of business hours. So evenings, weekends, and it's a multi-hour process. And then I think there's two key metrics: the number of hours you spend outside of normal business hours pushing out the release, and then also things like how many emergency fixes you have to put out afterwards. Those are kind of two useful metrics. But also, the other thing that's scary is, will all these new features actually deliver value to the business and to our customers? So finding out whether something you've built is actually valuable, again, the data shows. Ronnie Kohavi has a great paper. He's the guy who developed Amazon's A/B testing framework and then went on to Microsoft and built their experimentation platform for Bing. He has all this data from A/B tests that shows that 2/3 of the features that the people thought would be really good ideas deliver zero or negative value to customers. So if you generalize that data, 2/3 of the features we build deliver zero or even negative value to customers. They make things worse. That should be scary, and we should be finding out. A lot of companies don't even gather that data. And if you're working in 3-month releases, how do you work out which of those features actually are responsible for either the increase or decrease in the business metrics you care about, revenue per user or whatever?
Because so many other things change in that.
Right.
time.
So much has changed. How do you trace back to work out which of the things you did was actually valuable? Josh Karievsky talks about, he wants to be able to assign a dollar value to every line of code. Like, which are the lines of code that are actually producing value for me? We can't do that, but we can at least, if we're working in small batches and doing A/B tests, we should at least be able to see which of these features is actually delivering revenue.
And why makes automating releases and doing it more frequently releases less scary?
Which is a great question, because it seems counterintuitive, right? It seems if deploying is painful and you do it more frequently, it seems like that's crazy. And I think
sounds like more pain.
You're right. It sounds like more pain. But the thing is, you're deploying less stuff. So there's a few things. Firstly, you practice it more, and that means you get good at it. And it kind of forces you to simplify. I mean, the thing that has to go with automation is simplification. If you take a painful manual process and you just automate it, what you end up with is a painful, flaky, automated process, and it's not actually an improvement. And you need to re-architect your software to make it so that it's easy to deploy, which is the architecture piece. So there's a simplification that goes along with the automation. And so that reduces some of the risk. Doing it more frequently reduces some of the risk because you get to practice it. And then also, just because there's less stuff that's changing between releases, we're not saying take a 3 months worth of stuff and release that 10 times a day. We're saying take a 1/10 of a day's worth of stuff and release that 10 times a day, which might be just a single line of code or a single configuration change. And so when the amount of stuff you're releasing is much lower, if there's something goes wrong, it's much easier to find the problem and it's much easier to fix the problem.
Yeah. I would like to mention the word fix forward in this instance. Can you elaborate on that?
Yeah, so this is something we see in high performance organizations that have done this for a long time, is that they never roll back. They always roll forward if they find a problem. So one of the techniques that we talk about in the book is blue-green deployments. Blue-green deployments is this idea that you basically have 2 copies of production. And one of them is live and one of them is not live. You might call it staging. And what you do is you deploy to the staging environment, and then you switch the load balancer or router or DNS to point to the staging environment, and then staging becomes live, and what was live becomes staging. And this is something that Netflix have talked about. They call it red-black deployments. But what they basically do is they deploy to staging, and then they slowly migrate users from one to the other. And I think actually what they do now is Europe is their staging environment, basically. But because of that, what they can do is if they find a problem during deployment, they just switch the users back to the old live. And so as a result of that, they never need to roll back. They just redeploy a new build to the staging environment and then gradually migrate users to that. And then rollback is actually just pushing the users to go back to the main live environment. So yeah, I mean, organizations that are really good at this just keep rolling forward. I actually asked Diane Marsh, who runs engineering tooling for Netflix, do you even keep around your builds? And she's like, well, yeah, they're somewhere, but we've never rolled back. So we never need to redeploy old builds.
So does that mean that when I deploy more frequently, I'm also faster to fix if bad things escape live?
Yeah, because again, it's much quicker to change a router setting to do a, quote, rollback, unquote, than it is to try and redeploy a previous build. I mean, and also, this is not a practice we test very often. The reason that production deployments are different from deploying to staging, for example, or testing environments, is that you've got all this production data to worry about. So often rollback, especially if it involves data changes, that's actually a pretty high-risk process and not one that people test very often. So rollback can actually be very, very risky.
You mentioned A/B tests a couple of times. Can you explain shortly what an A/B test is and why it is important for continuous delivery?
Sure. So A/B testing actually came from mail marketing. So people who would spam your real physical mailbox with post advertisers, they would send different versions of their promotions to different people and see which version of the advertising copy produced the biggest response rate. And so how do you do this in software? Well, you have two different versions of a page. And you show some users one version and you show some users another version. And you have to track this throughout their entire session. So you create what's called a cohort, which is a group of users that come to the site at roughly the same time. And you track their progress through the site, including whether they saw version A or version B of a particular page. And then you see at the end of their journey, which has actually produced the desired business behavior, which might be something like Amazon, whether you check out at the end, or like how much you end up buying at the end.
Define a primary outcome.
Right. It's what's called the overall evaluation criteria for the experiment. And you see over time, and you have to collect quite a lot of data to get statistically significant information. So you collect that data over time with your cohorts and find out which version of the page produces the right outcome. And if you look at companies like Amazon, Bing, Etsy, they're running a number of different A/B tests in production. Tens or even in some cases up to 100 A/B tests, but they control very carefully which cohorts get to see which combination of variations, because obviously you don't want the tests interacting with each other.
Yeah. Multivariate tests are a pain.
Right.
Okay, let's switch our focus a little bit from why we are doing it to how does our organization, how does our culture need to change? In the book you say continuous delivery has its origins in lean. Can you explain what you mean by that?
Yeah. I think this is only something I realized as we were writing the book. I read Mary Poppendieck and Tom Poppendieck's book, Lean Software Development, back in, I think, 2004 or 2005 it came out. And that was a big revelation. And then as I was writing the continuous delivery book with Dave, we were still reading a bunch of other stuff on lean. And it kind of came to me that a lot of these ideas had their roots in lean philosophy. So one idea I like to talk about that comes from lean philosophy is jidoka, which is a concept that was actually invented in 1924 by the Toyota family. I think it was Takeshi Toyota, when they were working on looms. So Toyota used to build looms for weaving before they moved to cars, and their breakthrough product was the Toyota Automatic Loom Type G, which had this innovative feature that it could detect if there was a problem with the weaving process. So if a thread broke or if a spool ran out of thread, it would automatically stop and notify the user.
Something like continuous integration these days.
Exactly. And it's the same practice, right? Which is that something goes wrong, you find out about it straight away. And in the case of the loom, what this meant was, instead of having to have an operator for every loom, they could have a whole room full of looms and just one operator, because the machine would tell you when there was something wrong. And with continuous integration, which is exactly as you point out, an analogous process, again, instead of having testers manually inspect the software, you have automated tests in place and you find out straight away if there's a serious regression, and then you can stop and fix the problem straight away. And that makes the software process much more efficient. It's this idea of building quality in, this idea that Deming talked about in the total quality movement, that we're going to build quality into the software. So many of these ideas, including that one, come from lean philosophy.
Another thing you mention in the book about the culture is this idea to optimize cycle time. What is the cycle here?
And that's a great question. I mean, again, taking the metaphor of lean, the cycle time is very easy to define, because it's, you can actually physically watch the movement of inventory through the factory. You can see the cars going along the production line or whatever. With software development, it's much harder to be tangible about the inventory, which is, we don't
have so many cycles, we have iterations, we have...
Right, so it's like, are they features? Are we measuring, is features the inventory? And if so, how do we measure the movement of features? What's the starting point of a feature? Is it the point when you first have the idea? Is it the point when you move it, where you type the idea into a tracking system or write it on a card? Or is it the time at which you put it into your prioritized backlog? I mean, where do we even start the clock, right?
Yeah.
So I think
where would you start the clock and where would you stop it?
Well, I think for continuous delivery in a kind of very specific sense, the one place where it's very concrete is where you start having check-ins to version control. So I think, it's not the full cycle, and we need to be a bit careful about it to not exclude the kind of front end of ideation and analysis. But when you check in code into production, when you check code into version control and you measure how long it takes from being checked into version control to getting into production, that's very concrete and definable. And the production line metaphor that we use in the continuous delivery book uses the metaphor that the production line in software is the process of taking a change in version control and then running tests against it, turning it into packages, and ultimately deploying it to production or releasing packages to users, or release to manufacturing in the case of firmware or something like that.
Yeah. And this is what you call the deployment pipeline.
Yeah, the deployment pipeline.
And the deployment pipeline, is it just an automatic process? Can I just have a bash script which does the deployment pipeline?
Yeah, you can, although I think there will typically be manual validations. So in most cases, we wouldn't be happy taking software that's passed the automated test and deploying it straight to production. You'll want to do some kind of user testing, maybe A/B testing. And there's some kind of complexity with dark launching and so forth.
What is dark launching?
Dark launching. So this is a term that was invented, I think, by Facebook, and it's used by Etsy, where you take code and you push it into production, but those code paths are not executed.
So you toggle the features.
Yeah, you toggle the features, or you put them behind an API and nothing in the UI actually is connected to the API.
Yeah.
So that would be another way to do it. But yeah, for example, in Etsy, most of the code changes go out dark, and then they're kind of wired up subsequently, and that's a completely independent operation. And that can be done. Facebook have a piece of software called Gatekeeper, which controls for each feature exactly who can see it. So you can take a particular feature and show it to a particular demographic, or roll it out to 1% of users for the purposes of either A/B testing or for even final rollout, or even for managing load. So if you have unusually high load on your system, you can turn off some of the expensive features. That's something a lot of organizations practice. So kind of feature toggling, dark launching is useful for a number of different purposes, in fact.
I heard at some point that this means you separate release from deployment.
Yeah, that's something that I like to talk about a lot, that I really realized after the book came out.
It might have been you, but I really don't know where I know it from.
Yeah, I know. I mean, I certainly wrote about it. I don't know if I was the person who invented the concept, probably not. But the idea is deployment is taking a build and putting it into an environment. Release is making a feature available to users. And those are two completely independent operations. Often we couple them. We achieve release through deployment, but that's actually very risky. A much less risky way to do it is to launch all the features dark, which is deployment, and you're doing that all the time. But then release, in the sense of making features available to users, is a much more gradual, incremental process that happens completely out of band. It's totally orthogonal to the deployment process, and it's done by the business, by doing A/B tests, by gradually ramping up functionality,
and switching them off when they're broken.
Yeah, switching off if it's broken or if there's high load or something like that.
One large part we haven't talked about yet in continuous delivery is the operations part.
Mm-hmm.
So how is continuous delivery linked to what we call DevOps and the DevOps culture?
Yeah, that's an interesting question, because the DevOps movement was basically becoming widespread around the time we were writing the book, to the extent that we actually got the word DevOps into the book. I remember kind of reading a bunch of stuff about DevOps and talking to a bunch of people about it and getting very excited about it. And
would you today name the book the DevOps Bible or something like that?
I know. I'm quite happy with the title of the book. Actually, I think that worked out quite well. But I think DevOps is definitely part of it. I think DevOps came from the WebOps movement, and actually the book that came out before continuous delivery was Web Operations.
What is Web Operations and why is it different than DevOps?
So Web Operations was, it's this book that was edited by Jesse Robbins, who is head of ops, master of disaster at Amazon, and John Allspore, who at the time was head of ops at Flickr. And it's actually not nearly as well known as it should be. It's a whole collection of essays by people including Andrew Schaefer and Eric Ries and a bunch of other people who are very well known today, but at the time weren't so well known, about how to build web scale systems like Facebook and Amazon and so forth. So Web Operations was people working out how to build large scale websites. And so that's where the DevOps movement came from originally.
So that other systems except web also can do WebOps stuff.
They didn't really care about those things. They didn't care about building user installed software, packaged software, firmware, anything like that. They were purely focused on high volume websites. And DevOps really came out of that. And they weren't really focused on any of the other domains at all. Whereas continuous delivery came from a slightly different background. And I think what we found is that a lot of the ideas in terms of the lean philosophy, the practices and the culture ended up being the same. And that was really what was very cool about it, and I think led to it becoming such a paradigm shift, is that we found that the same ideas around culture and practices were the same that across different domains, from building highly scalable websites to building firmware to building packaged software, that actually you could apply the same ideas across these different domains and have these really good outcomes, because fundamentally it was about building resilient organizations and about cultural shift as much as it was about the particular practices you use. And, one of the things that annoys me is you'll go into places and they'll say, well, that sounds great, but that can't possibly work here. We're not Facebook, we're financial services. And the problem
there is some truth to it.
Well, there is and there isn't. I think the problem is I have seen these practices work in the context of financial services. Now, I worked in an investment bank for ThoughtWorks in 2005, where we implemented a bunch of the practices in the continuous delivery book, and they were very effective, and they made a big difference. So I know that it's not. I was working on systems that would price swaps, hundreds of millions of dollars worth of assets. So there was significant amounts of money at risk here. And And we were using these practices because they actually make it safer. This is the thing. People say, well, it can't work here. Really? Improving the quality of your software and finding bugs faster won't work here? Gosh, and this is what I find kind of ironic, is that you go to these places and they say, oh, that can't work here because we're risk averse. These practices are designed to make it lower risk and higher quality. So what you're saying is we don't want to do that. We want to continue doing all these kind of cowboy practices that actually make things worse. I was involved in the State of DevOps report this year, 2014 State of DevOps report. And there'll be a link in the show notes for this. And one of the things we looked at is we measured IT performance in terms of throughput, which was release frequency and change lead time in the way we defined it earlier, and also stability in terms of time to restore service when there's an outage or a degradation, and change fail rate, the percentage of changes that fail after you deploy where you have to put a hotfix or roll back. And what we found is the kind of heavyweight change management processes that a lot of these organizations use, like having change advisory boards and so forth, obviously they decrease throughput. They make it slower to get changes out. But the really surprising result is they do nothing to improve stability. So we compared people using those kinds of heavyweight change processes to organizations that use peer review, where developers check each other's work either through a lightweight change approval process or through just pair programming. And we found obviously that creates much higher throughput. I was expecting to see that reduce stability, and the surprising result was that it did not at all. It's as good at creating stable systems as heavyweight change management processes. So this idea, it can't possibly work here, it's just wrong. And psychologically, I understand why people think that, because they think, we're not Amazon, we have different problems. But they forget, Amazon has Sarbanes-Oxley. They're a listed company. They have PCI DSS. They process probably the largest number of credit card transactions of any company in the world, or certainly that order of magnitude. So they're subject to these regulations. I think the mistake people make in these large organizations is they take a one-size-fits-all approach. They say, these are the regulations and we're going to apply them to all the different systems. And high-performance companies don't do that. They say, well, actually, not all of our software is involved with credit card processing. Only this particular service is doing the credit card processing. So what we'll do is we'll limit the scope of the regulation to as small a surface area as possible and architect so that the software that does that is as small as possible. And so you take a very nuanced approach to risk management, where you say, well, actually, where is the locus of these risks? And how can we apply risk management in a way where it doesn't impact the whole system, and where this system, where we don't care about PCI DSS, developers can push changes to production, but this system where we actually do have credit card data, we're going to take a more nuanced approach. But then also, Etsy has PCI DSS. PCI DSS specifies segregation of duties. In other words, that the person who approves the change can't be the same person who writes the code. Nowhere does it specify that those people can't sit next to each other. So, for example, at Etsy, the people working on the PCI DSS environment, they all sit in a room together. The ops people, the developers, the testers, they all sit in a room together and they talk to each other all the time. And implementing these regulations in a way that follows the spirit and the letter of the law, but not in a very kind of heavyweight, segregated way, is also important.
Yeah. I read you a quote from the book, which is, everybody is responsible for the delivery process. Is that a summary of DevOps?
Yeah, it's a pretty good summary. Everyone is responsible for the delivery process. That's right. I think everyone is responsible for everything. If you look at high-performing organizations, developers consider themselves responsible for business results. There's not this thing where, this is my job, this is my role, and anything outside of that is not my problem, it's someone else's problem. In high-performing organizations, people don't think like that. They think that everything is my problem, and it's not, this is my bit, and if this thing gets screwed up over here, that's their fault. You don't have this mentality. And we create cultures where people do feel that they're responsible for everything. The question we asked in the State of DevOps report is, when dev and ops interact, is the outcome usually win-win? And that was the key question that brought out the DevOps thing, was, Was it win-win when these things interact? But if you look at the kind of cultural substrate that creates those good outcomes, it's that, developers consider operations part of their responsibility. It's, if something goes wrong in ops, it's not, oh, well, it must be ops' fault. They're so dumb. And likewise, if deployment process fails, it's not like, oh, the stupid developers. You actually work together, and we organize our companies in a way where people are as closely as possibly connected to customers. So developers are connected to customers. Everyone's connected to customers, which is another idea that comes back to lean.
How important is that the ops people, or the people focused on ops and the people focused on dev, sit next to each other?
I actually think it's pretty important. I want to be careful about this. There's a great quote, a really good book that I love about lean is by a guy called Mike Rother, and it's called Toyota Kata. And Toyota Kata is a book that describes the management philosophy of continuous improvement that Toyota follow, and it's really key to implementing many of these ideas. One of the things he says is that it's not the form of the organization that's decisive, it's the behavior of the people. And so a lot of companies undertake reorgs in order to achieve some of these things we talked about. And reorgs are neither necessary nor sufficient for achieving these outcomes. What has to change is people's behavior.
And how do I change people's behavior if not sitting them next to each other?
That's a great question. And I think that's absolutely right. I mean, sitting next to each other is one way to do that. And certainly if you look at companies like Google and Facebook, certainly Google, I know, they have a service, that they have these services, and they're not 2 pizza teams. I mean, they're not 10 people, but some of these services, there's maybe, tens of people involved together, and they make sure they all sit on the same floor. So you might have a desk of a bunch of engineers sitting together and this desk with a bunch of ops people, and they're not on the same table, but they are in the same floor and the same space.
But Google and Amazon have all the light-minded, forward-thinking developers and not the old guy who doesn't want to change.
Right. So there is an element of that. And I think, my favorite story about culture change is actually a case study from Toyota again. So sorry to bang the Toyota drum, but it's just a source because they've been doing it so long. They have so many great stories. So there's a podcast on This American Life, which is actually one of my favorite podcasts. And it talks about NUMMI, New United Motor Manufacturing Company, which was a joint venture that was set up between Toyota and General Motors in America. So I live in California, and actually the NUMMI plant was in Fremont, and it was on the same site as a previous GM plant that was called Fremont Assembly. So Fremont Assembly was shut down because the quality of the cars they were producing was really horrible. And the people on the production line were really miserable. They hated their jobs, and it got to the stage where they would do things like sabotage the cars by putting empty Coke bottles in the doors so that they rattled around when people shut them. And they would do things like drinking on the job. And so the plant got closed down because it was just so cost inefficient and poor quality. And so Toyota wanted to come to America to produce cars in America because Congress was imposing tariffs on foreign manufactured cars. GM wanted to learn how to build small cars because GM, all the American cars at the time were very big gas guzzlers, and they had not worked out how to economically produce the kind of small cars that Toyota was producing. So they set up this joint venture in the early 80s. And what they did is, which was really radical, was they took the same workforce. The union leader at Fremont Assembly convinced Toyota to rehire the same workforce, which is kind of a nuts thing to do. But they rehired them and they sent them to Toyota City in Nagoya in Japan and trained them in the Toyota production system. And then they all came back to start at the NUMMI plant. And within a few weeks, they were producing cars which were the same quality as the Toyota cars produced in Japan. They were making Camrys, and they were producing cars that were much better quality than anything that GM was producing in America at the time. And what that showed was it wasn't the people that were the problem. It was the system that was the problem.
What did they do? Except sponsoring them a great trip to Japan.
Right. Well, that was one element of it. And another element was the fact they'd just been fired. So they were kind of ready to do anything, which are both very important. I think that can't be discounted. But I think the key thing that's different about the Toyota production system is, and on the podcast, they kind of talk about it as it's being teamwork. It's that everyone works together to achieve customer outcomes that we want, which is kind of what we talked about earlier. So the kind of the practice that everyone talks about is being able to stop the line. So at the old GM plants, what would happen is the plants, if you've got a car, the way it works is the car goes along the production line and you have a certain amount of time as a worker working on a particular thing to do your part of the process before the car moves out of your area somewhere else. And if you can't, for example, get the door bolted on within the time you have, sorry, that car's now going to someone else. And so what would happen is cars would roll off the line with things done badly or not working properly, and they would get pulled off the line at the end and put into kind of a parking lot to be fixed later. That's not the way things work at Toyota. At Toyota, if you can't get your work done in, I don't know, something like 2/3 of the allotted time, you can pull a cord called the andon cord, and that will light up a signal, and a manager will come and help you. And the idea of the managers actually helping you is pretty radical for GM people at the time, because it was a very antagonistic relationship. But at Toyota, the manager will come and help you, and if you're not done by the time you have available in total, you can pull the cord again, and it will stop the whole production line. And that was crazy talk for the people at GM. And people don't realize how often the andon cord gets produced. You might think it gets stopped a few times a day. The andon cord in a typical Toyota factory gets pulled thousands of times a day. That people find problems all the time.
Stop off the line, or I need more help line.
But the I need help happens thousands of times a day. And
but the other one probably only a few times a day.
Yeah, I don't know actually how often the production line stops, but it definitely does stop. That's an okay thing to do. And that idea that everyone is working together, and that the most important thing is, and it's the Jidoka concept again, the idea of building quality in, that was totally different. And so John Shook, in a paper, I think for Sloan Management Review, says that the big thing that changed was giving the workers the tools and the skills and the training to do their jobs, and giving them the power to achieve the customer outcomes they wanted to achieve. And those behavior changes were really fundamental.
Mm.
So again, implementing continuous integration, allowing engineers to choose their own tools, allowing engineers to push stuff out to production, and giving engineers the ability to affect customer outcomes, and the ability to learn for customer outcomes, and putting them in contact with the customers and giving them the tools to do their job. And then also telling them what the business outcomes that we all want as a company are, and not telling them here are the features we want to build, but instead telling them here's the business outcomes we want to achieve, and you work out the features you want to build. That's the analogy.
Yeah. So let's switch from the culture. Now let's talk a little bit about the practice. And from what you're saying, one of the most important practices is to have everything in version control.
Yes.
Why is that so?
So having everything in version control is important because for a couple of reasons. Firstly, so you can do system level automated tests. So for example, it's much easier, as I like to say, to bring down a web system by changing a firewall setting than it is by changing a code setting. So we should be testing those high risk changes with the same rigor that we test code changes. And things like software defined networking are going to make that even easier in the future, I think. But we need to test database schema changes, all those different kinds of changes. So unless that stuff's in version control, you can't automate the provisioning of those kinds of things and running database changes in as part of the automated test process. The other reason it's important is for those stability metrics. So we talked about how time to restore service was an important metric. In the event of a disaster, you need to be able to restore service in a predictable amount of time. And the only way you can do that is if you can recreate the configuration of your production systems from information stored in version control. So just from a disaster recovery point of view, it's really important to be able to do that. Everything apart from your data should be in version control. And so, as is almost always the case, the same things that help increase throughput are the same things that improve stability. So having stuff in version control contributes to both of those things. It improves throughput because it allows you to provision testing environments much more quickly. It also improves stability because it allows you to do deployments and disaster recovery much more quickly as well.
So you gave a talk shortly before this interview, and you said if you're doing branches, you're not doing continuous integration. Can you explain that to the people who have not been on the talk?
Yeah, this is still, in 2014, probably the most controversial thing I say, is that feature branches are basically a bad idea. And I kind of use that as a slogan, and the truth is more nuanced than that. The problem is not feature branches. The problem is long-lived feature branches. And in particular, the problem is feature branches with a lot of changes on them.
Yeah. So I'm still okay to do my spike branches and delete all the code afterwards.
Right. The problem is not actually branching. The problem is merging. The problem is when you merge, if there's only 2 developers, it's fine. But as the number of developers increases, what you find is, say I'm working on some code on a feature branch, and I get towards the end of my feature, maybe it's taken a few days, and I find some really nice refactoring that will make the code a lot nicer. So I add that refactoring and then I push to master. Now at that point, you've been working on another feature for maybe a few days. You pull my change, which includes my refactoring. That's actually going to be a bit of a pain for you to merge that refactoring in potentially, especially if your architecture isn't ideal. And the pain of that increases non-linearly with the number of people on the team. So the more people you have on the team, the more painful that merging becomes. And the longer the length of the branch, the more painful it becomes. And it actually inhibits good practice like refactoring, because the moment I do a refactoring and force everyone else on the team to take it, if they've been working for a few days on something else, all of those other people are going to have to take that merge, and it's going to impact all of them. And then you're not going to be very popular, right?
Just to clarify it, by merging, you don't mean the technical merge conflict with Git, because with Git, merging has become so much easier on a code level.
It has, but there's also semantic merges. So text merges is one thing, but I've certainly experienced it. I'm sure you and many of the listeners have experienced it, where you had a change that merged perfectly fine, but it still broke something. Because what changed was not a conflict between 2 lines of code, but a conflict between, one thing used to call one function or one method, and now it's calling another method, and I changed that method. So there was no conflict, but the behavior of the system changed, and we didn't catch that.
And if you're lucky, your compiler or your unit test catches it.
Well, yeah, your unit test will catch it, absolutely, if you've done a good job doing that. But again, that will only be caught once those 2 changes that conflict semantically are on the same code base. And that can't happen if we're just merging from master onto our feature branches. It only happens when the feature branches are merged with each other. I mean, the only way you can get to production is when all the feature branches are merged. And that is a combinatorial problem. It's not a linear problem.
All right. So one part of having everything in version control is obviously configuration management. What is configuration management?
That's a great question, because it's going to be used by different people in different ways. I think configuration management is just working out how to turn the bits in version control into working systems.
Yeah. So, and we are talking of tools like Puppet, Chef, and Ansible, or...
Yeah, I mean, there's a whole range of them. Obviously, I'm the Chef guy, so I'm gonna say that works pretty well. But yeah, there's a whole range of tools on the market for taking bits in version control and turning them into working systems. And normally it's not just going to be a configuration management tool. There's going to be a bunch of other stuff you need to do things like creating packages for your software. And, obviously you have to, everything is in scope, right? Including networking, storage,
configuration of firewalls or application servers.
Absolutely. Everything you need to reproduce working production systems is in scope. And so that's becoming easier, but it's certainly not a solved problem.
Yeah. Recently, there also has been a movement from going from configuration management to moving it more to container visualization, like you would do with Docker.
Mm-hmm.
Does this add something to the table for continuous delivery?
Yeah, I think this is kind of pioneered by Netflix. Netflix had this idea that the unit of deployment and the unit of packaging would be an AMI. So they had this thing.
AMI are the virtualization things for Amazon, right?
Yeah, AMI is an Amazon machine image. So what they would do for their deployment pipeline in Netflix is create an AMI, and that machine image would move along the pipeline to production, and so that would be the unit of packaging and deployment. And they have a tool, I think, called there's one called Bakery, which produces that AMI and moves it along the production line. And so I think what you've seen, tools like Docker, like you mentioned, is actually moving to that as the unit of deployment. And that has profound impacts, not just for the way you manage the lifecycle in production. It also has profound implications for developer lifecycle. I think, Vagrant revolutionized the way we were able to test our software by making it possible to create production-like environments on developer workstations. With tools like Docker, it becomes possible to take the same things and use them all the way through the process from developers all the way through to production. So yeah, I think that is profound. You have to architect your systems with that in mind. So if you're not working on a greenfield system, it's going to be very hard to try and retrofit that in. And also, there's always going to be a place for tools like Chef for configuration management tools, because it's not just about that, it's about all the supporting infrastructure as well. So there's a high level kind of orchestration piece, and also all the stuff that's not just the container that you have to wire together to get it to work properly.
Yeah. We recently had an episode about Vagrant. We will have upcoming episodes on Amazon Web Services as well as on Docker. So you might stay tuned to the show to learn more about these tools. I think we pretty much covered what I wanted to say. Is there anything you want to say which I didn't ask for?
I think the only other thing that I found really interesting, especially doing the State of DevOps report, was that we were able to quantify culture. So we talked about culture earlier on in the show. The model we used to quantify culture was by this guy called Ron Westrom. And he was a guy who's a sociologist who was studying safety in the context of healthcare and aviation. And he created this model that allowed him to predict safety outcomes in these companies. And what was interesting was that we used this in the State of DevOps report to measure people's culture, and it predicts IT performance. So the same model that predicts culture also predicts innovation, stability and throughput. So that was kind of a big eye opener for me. And again, the State of DevOps report is going to be in the show notes, and you should download it and check it out to find out what the Western model is. That was actually sent to me by John Allspore. John Allspore, who's now head of ops at Etsy, it's basically, I'll email him and he'll just reply back with a PDF of some paper he's read recently that he really likes. And so I get a lot of stuff from him in that way. And this is one of those things that you would never have known about. He's studying for a master's in safety at Lund University in Sweden and talking to all these people in aviation. And so that's another thing that is a big eye-opener for me, is the extent to which we can learn so much by collaborating with people in different industries and domains. And these models that have been used for years in other domains actually have a really important implication for software development.
Yeah. Maybe leading from that, you recently moved from ThoughtWorks to Chef. How will people be able to collaborate with you? What is your role as VP there?
So at Chef, I kind of have an internally focused role where I'm helping to build an organization that moves fast at scale. So taking a lot of the stuff that I'm talking about in my forthcoming book, Lean Enterprise.
Which will be discussed with your co-author
yeah, so
in a month or so.
You're going to have Barry on the show to talk about the Lean Enterprise. But that was a book that was fundamentally designed to help people address all the organizational, cultural, and architectural issues that prevent them from doing continuous delivery. So all the things we talked about earlier, where companies said, oh, that sounds great, it can't possibly work here because XYZ. Well, we address XYZ in the Lean Enterprise, finance, governance, risk management, project management, portfolio management, all that is covered in the book. And so basically I'm taking a lot of those ideas and using them to help Chef move fast at scale.
Okay, cool. How can people find out more about you? You're on Twitter?
Yep, so I'm Jez Humble at Twitter. I have a website, continuousdelivery.com, that you can go and check out there. I'm Jez at getchef.com. But yeah, Twitter's normally the best way to get in touch with me.
All right. That makes the episode. Thanks very much for your time. I think it was very interesting.
Thank you very much for having me.
Thanks to you for listening to this show. You will find all the books mentioned and links in the show notes. So thanks very much. I'm Johannes from SE Radio. Goodbye.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.